on 10.2 telescoping series, they're asking us, do the following series converge or diverge? If they converge, what do they converge to? The only way we can find what a series converges to or find its sum is if it's a telescoping or a geometric series. If it's a telescoping, we can do it manually. If it's a geometric series, we have a formula for it. After these sections of telescoping and geometric, we're never going to ask what does it converge to, because then it becomes just too hard and we don't have the tools for that yet. So we just simply ask if it converges or diverges. But right now, with telescoping and geometric, we can do both. We can find out if it converges or diverges and what it converges to. Let's go ahead and do this first one. Remember, the whole idea is when you're trying to work with a telescoping series and you want to find what the actual sum of the series is, it's really just the limit as n approaches infinity of the sequence of partial sums. We've talked about this right over here. Limit as n approaches infinity of the sequence of partial sums. But first, we actually have to find what S of n is. So how do I do that? Well, S of n is really just a sequence, and it's called a sequence of partial sums because it's just the sum up until 1, then the sum up until 2, and then the sum up until 3, and then the sum up until 4, and so on and so on. So what I like to do is I like to write them here on the side. So S of 1 is literally just a sum up until n is equal to 1, meaning you plug in 1 here. So that's going to be 1 plus 2 is 3, and then 2 plus 3 is 5, minus 1 plus 3, 4, and then 2 plus 5 is 7. And then S sub 2 is a sum up until 2, so that includes the sum of 1 plus the sum when you plug in 2. That's going to be 2 plus 2, that's 4, over 2 times 2 is 4 plus 3, 7, minus 5, and then 4 plus 5 is 9. And then we're going to continue with S sub 3, right? S sub 3 is going to be the sum up until 3, so that includes the sum of 2, which is really the sum of 1, and then 2. And then S sub, you plug in 3 here, so 3 plus 2, 5, 3 times 2, 6, 7, 8, 9, and then we have minus 3 plus 3 is 6, and then 3 times 2 is 6, plus 5, that's 11. Then we'll do one more. S sub 4 is really just S sub 3 plus the sum of when n is equal to 4. So then we have 4, 4, 4. So 4 plus 2 is 6, 4 times 2 is 8, 9, 10, 11, and then we have minus 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13. And I really just stop here. At this point, you ask yourself, okay, what's the pattern? I look at this and I'm like, well, I noticed that the 3/5 is always there. And then what I notice is that here, these cancel out, and then this is what's left. These cancel out, and then this is what's left. These cancel out, and then this is what's left. And so the pattern that I'm noticing is that the first term, 3/5, is always there, and then the last term is always there, but it's different each time. What's a way to represent the last term? This is literally the last term. So just like this is -4/7, I got that by plugging in 1, right? So 1 plus 3, that's 4. This is 7. This is the last term. When you plug in n, so for any n, it's always going to give you the last term. So in this case, the last term is going to be n plus 3 over 2n plus 5. And that is what your S sub n is going to be, because everything else just cancels out in between. So the whole idea is recognize what's canceling out and then pick what is left. And so now you know what your S sub n is. So what you can do is you take the limit as n approaches infinity of S sub n. And so that's going to be 3/5 minus n plus 3 over 2n plus 5. And because these are limits, you can just separate them. So this is just a constant. And so this just becomes 3/5. And then this is a fraction. Divide each term by n. This becomes just -1. This is 3 over n. The n's here cancel out, so it becomes 2. If I plug in infinity now, this goes to 0 and this goes to 0, because one whole divided into infinitely small pieces just goes to 0, becomes infinitely small, right? That whole becomes infinitely small. Because if you have one pizza and you divide into infinitely small pieces, it's just going to become invisible. It's just going to become like so small, so 0. And so really we're just left with -1 over 2. That's 3/5 minus -1 over 2, so that becomes a positive. And so 3/5 plus 1/2, and so the limit is 11 over 10, meaning that this series converges, and it converges to 11 over 10, and that is your answer.